we're now going to graph functions. And as you've probably guessed by now, we're going to use point plotting quite a bit, so we're going to talk about point plotting again. Mostly because it's the single most important method to remember, because you can use it to graph anything. So let's start with the function. F of x equals the absolute value of x. Remember that the absolute value says how far from 0. It doesn't care about the sign. It just cares about its distance to 0. So if it's positive, it stays positive. If it's negative, we make it positive. And so this is important because it's going to help us do our point plotting. So we're going to pick the points. Here's x. And we're going to change our table to represent f of x, because remember, f of x is y. It's the value at x. So we're going to start with some values. Let's go with -2, -1, 0, 1, and 2. And I'm picking more than normal because of the absolute value. I want you to see what happens. So when we plug in the absolute value of -2 is 2, -1 is 1, 0 is 0, 1 is 1, and 2 is 2. And we get this graph that looks like this. 1, 1, 2, 2, -1, 1, -2, 2. And we get this V shape based on that graph. And all absolute values have a V. It's just a matter of where does that V take place. So let's look at another example. Suppose I have f of x equals the absolute value of x plus 1. So again, we're going to take our x value and we're going to take our f of x value, and we plug in -2, -1, 0, 1, and 2. But now when I take the absolute value of -2, it becomes a 2, which I then add 1 to, and I get a 3. Same thing's going to happen with the positive 2. The absolute value of -1 plus 1 is 1 plus 1, which is 2. So we get a 2 there and a 2 there. The absolute value of 0 plus 1 is 0 plus 1, which is 1. So our points are -2, 3, -1, 2, 0, 1, and 1, 2. And you'll notice this graph looks similar to the other one, but every point is 1 higher, because I added 1, oops, let me put that in the right spot. I added 1 after I took the absolute value. Now, the next thing that we have to worry about is what happens if I take the absolute value before I take the absolute value. So if I add to it before I take the absolute value. So now when I pick my values, -2, -1, 0, 1, and 2, I'm going to get -2 plus 3, which is 1, the absolute value 1, which is 1. And I'm going to get -1 plus 3, which is the absolute value of 2, which is 2. And if you notice, each time we can use our slope idea, because it's always getting bigger at the same rate. So we're going to have a 1 here, a 2 here, a 3, a 4, and a 5. And if I try and graph this right now, it looks like we're getting the following graph. -2, 1, 2, -1, 2, 0, 3, 1, 4, and so it looks like I'm getting a graph like this. And so if I just try and do this, because I know it's got a V, I'm going to be wrong. So this is wrong, because I haven't found where it turns around at yet. In order to find that, I need to find out what's going to give me 0. And so when I take this, if I plug a -3 in, -3 plus 3 is the absolute value of 0, which is 0. And so there's my 0. So I actually have a point here. And if I try -4, I'm going to get -4 plus 3, which is -1. And so that's going to go up. And so my real graph looks like this. So the key points to choose are centered around what makes the inside a 0. And so that's where you want to point plot around.